this first one should be a pretty straightforward one for us. Solana, what do you think we should use for the u for this one?
3x.
Very good. So u needs to be 3x, which means that du, what will we get for that? With a dx behind it. So we've got right here, we can use this for our u. Do we have everything that we need for our du? We need to squeeze a 3 in right here. If we do that, what do we have to put on the outside? 1/3. Very good. We're replacing this with a du. So if we switch this stuff over to u's now, we've got 1/3 integral of sine of u du. When we integrate sine of u, what do we get? Negative cosine. So we're going to have 1/3, and I'm going to make it negative cosine of u plus c. And then we would put our u back in. So we'll get negative 1/3 cosine of 3x plus c. And that would be our answer. Okay, questions on that one? Those are pretty straightforward on what we need to do. Let's look at this one. This one, I think, is a little bit tougher. We got sine of 5x, cosine of 5x dx. Okay, whenever you guys see this, what do you want to use for the u? 5x feels like the right choice. It is not the right choice, but let's look at what happens. You don't necessarily want to write this down, but let's look at what happens. I'm going to write it out like it was 5x. So if u is 5x, then du is just 5 dx. So that is okay. And so I could put a 5 right here. I could put a 1/5 out here. That'd be fine, right? So I would have to replace this with u, and this with u, and this with du. So this would turn into 1/5 integral of sine u cosine u du. The problem is, do we know how to take the integral of sine u cosine u? We do not. That is not one of our trig integrals that we know, right? That's not one of those special rules. If it was like secant u, tangent u, we could do that because we had a special rule for secant x, tangent x. But we cannot integrate this. So while everything I've done up to this point is fine, this is a dead end, and you cannot do it this way. So how in the world are we going to do it? Let's look at it. We'll rewrite it here. So since 5x did not work as our u, we're going to have to use something bigger than 5x. Let's say that we use sine of 5x as our u. Okay, so u equals sine of 5x. Okay, what is du? It would be cosine of 5x, but I'd have to use a chain rule to take that derivative. And the derivative of the inside is 5, so I'd have to multiply by 5 out front, and I'd put a dx over here on the end. Do I have that for my du? Almost, right? The only thing that's missing is a 5, and can I put a 5 in there? That'd be fine, right? As long as I also put a 1/5 out front. And so I could make all of this stuff right here my du. So when I rewrite this, I'm going to have 1/5 integral of, there are no sines and cosines. You are writing sine of 5x is u. And all this other stuff is du. And then how do I integrate u? Add 1 to my exponent, so I'll make it u squared. I'm going to just leave this 1/5 right here. Then I would multiply out front, or divide out front by the 2, so I'd get 1/2. Put a plus c over here on the end. So I've got 1/10 u squared plus c. And the last thing I need to do is plug in my sine of 5x for my u. So I'd get 1/10 sine of 5x squared plus c. You will probably see this written this way. 1/10 sine squared of 5x plus c, because they just generally like to write it that way. Although the line before it would, of course, still be correct, and on FRQ would be fine. Is that the only way I could have done this? Because what's the derivative of cosine 5x? Negative sine 5x, which I could also do, right? So you could let sine be your u, or you could let cosine of 5x be your u. What's weird about this is you get a very different answer if you let u be cosine, because you're plugging cosine back in. So you end up with an answer that's like cosine based. Now you could like use trig identities and turn one into the other. So they are still equivalent, but they look a lot different there. So as far as how you know which one to do, if it is free response, it does not matter. They will accept either answer. If it is multiple choice, look at your answer choices and see if you've got sines all in your answer choices, or if you've got cosines, and that'll help you decide. Okay. All right, questions? All right. All right, let's look at this one. I start to think that it's hard to tell what the u is on these problems. It was pretty easy yesterday. There's only one correct one on this one. What you kind of want to think about is what you know how to take the derivative of, or what the derivative would be if you let it be your u. Because when you whatever your u is, when you take its derivative, it needs to be in there, right? So like the derivative of secant is secant x tangent x. Like there's a maybe it could work. I think that cube is going to mess us up for that. But what's the derivative of tangent? Secant squared. So since the derivative of tangent is secant squared, then it is probably going to be in our best interest to let our u equal tangent of 3x. And so du would be derivative of tangent is secant squared. Leave that 3x alone, but you need a little chain rule right here. You have to multiply by the derivative of the 3x, so you'll have a 3 out front, and I'm going to put a dx right here. I almost have my du because I've got that secant x squared 3x dx, but I need the 3. So if I add the 3 in right here, what have I got to do out front? 1/3. There. So now this can be my du. Okay. This stuff right here, not including that cube, is my u. So that looks a little bit weird because of the way we write exponents for trig stuff. But what that really means right there, this stuff right here is tangent of 3x to the 3rd power, right? So what we can do here is we can rewrite this 1/3 the integral of u cubed du. Not always, but a lot of times the trig goes away completely once you switch to u's. It's going to come back at the end when you sub back in. And so if we get just to u cubed, this is just a power rule integral. So we'd have u to the 4th power. I'm going to leave that 1/3 out front. I'll have a 1/4 out here. I'll put a plus c. And then I'll have 1/12 tangent of 3x to the 4th power plus c. You are more likely, though, to see this written 1/12 tangent. They'll probably put that 4th power right there, 3x plus c. Questions? All right. Moving on. Do I even want to do this? I'm gonna skip 4. Let's skip 4. Let's go on to 5 because we got FRQ. We got to go over. We don't want to. You would need a negative exponent. But let's do this one. It is. It doesn't feel like it though, right? It does not feel like it seems too simple to need a du for this. But you can't just integrate the denominator here. You could write it like a -1 exponent, but what's that problem with a -1 exponent? It's a natural log, right? Because when you try to increase -1 by 1, you get 0. So we're going to see a natural log show up in this problem, which to me is kind of crazy because it seems like it shouldn't have anything to do with a natural log. Like it's weird that that shows up. I feel like whatever mathematician like discovered this had to be like kind of confused that it was even showing up there. But if you see a fraction problem like this and it's asking you to integrate, it's not always, but it is a lot of times, the denominator that needs to be your u in this case. So I'm going to let u equal 3x minus 2. And so that means that du would be 3 dx. And so like we've seen on many of these, we don't quite have the du. We need a 3 to go over here with the dx so that we can call it du. But if we put the 3 there, what have we got to do out front? 1/3 right there. And so this stuff on the bottom right here is our u. And we can convert this stuff over to 1/3 integral of 1 over u du. And the integral of 1 over u is natural log of the absolute value of u. So you're going to get 1/3 natural log absolute value of u plus c. And we got 1/3 natural log absolute value of 3x minus 2 plus c. So it's not always the case, but a lot of times whenever you have a fraction like that, the denominator needs to be the u. Often the natural log will show up in that. Okay, questions there? All right, let's look at example 6. So here we are integrating x squared over x to the third minus 8 dx. Realizing Mr. Shear's not here to shut my door today. You can if you would like. The children are a little rowdy today and every day.
This is quieter than normal.
It's been worse, yes, definitely. Definitely.
Rush wood off isn't on the wall anymore to like get on.
Yeah. Yeah.
For sure, doesn't want to deal with any middle schoolers, and the 3-year-old also don't want to deal with any middle schoolers.
Yeah.
Nothing happens.
I don't really let myself get worked up about it. I just shut the door. You can't hear them if you shut the door. So if they get loud enough where you can hear them when they shut the door, then we have a major problem. It is amazing how soundproof that door is because they're kind of loud. All right, so in this case, there's kind of a lot going on there. It's not always the denominator that needs to be the u, but a lot of times it is the denominator that needs to be the u. So in this case, if I let my denominator be x to the third minus 8, then du would be 3x squared. Derivative of 8 is just 0, but I do need a dx over here. Now, I do have an x squared. I'm missing a 3. It's not really with my dx, but would it be acceptable to write this as 1 over x cubed minus 8 times x squared dx? Because this stuff is not in a fraction, so it would be over 1, right? So if I multiplied that back together, that x squared would still be in the top of the fraction, right? So I'm just like breaking that fraction apart by doing that. So I've pretty much got my du over here. I just need a 3 with it, which means I need a 1/3 out front. So whatever is in the numerator of that fraction can sort of be pulled over to the side to go with the dx there. And so that would mean this stuff right here would be my u, and this stuff right here is the du. That 1 that I had there was just to show you guys it's in the top of the fraction. It's not really part of anything, or you can include it. It's just dividing by 1. It doesn't change anything. So we will get 1/3 integral of 1 over u du. And when we integrate 1 over u, what do we get? Natural log of the absolute value of u squared plus c there on the end. So our last step there would just be substitute back in natural log absolute value of x to the third minus 8 plus c. Questions? Okay, let's keep moving. All right, let's look at this one. Because we need to definitely do this one to show that the u is not always the denominator when you have a fraction. So, in this case, the last two that we did, the denominator was the u. But if I let the denominator be u here, x is just u is just x, right? Which really doesn't do anything except for change your x's to u's. It doesn't help at all. So what do you guys think I should use for my u in this case? Okay, what, the whole thing? Just the natural log right there. So u is going to be natural log of x. So the cube does not go in there, just the natural log. What is the derivative of natural log of x? It is 1 over x, and we will put the dx over here with it. So this right here is my u. Do I have what I need for a du? I do. It's just like, it's just in the fraction over here with it. I could sort of pull it out, right? So just to be very clear, I'm going to rewrite this a little bit right here. We could rewrite it as natural log of x to the third times 1 over x dx. And then that would be my du. And of course that natural log of x right here is my u. So it is there, even though it doesn't look quite the same whenever it's in the fraction. So if we switch to u's now, we've just got u to the third du. We will just integrate using that power rule, u to the fourth, divide out front by that 4, put plus c. And so we get 1/4 natural log of x to the 4th power plus c. Okay, questions? Moving on. All right, let's look at this one. First of all, what is this the integral of? Like, could I simplify that a little bit? Sine theta over cosine theta. It's tangent. This is the integral of tangent, right? Do we know a special rule for the integral of tangent? We do not, right? We know how to take the derivative of tangent, but that is secant squared. So we only know how to integrate secant squared. We don't know how to integrate tangent. So when we get our answer, we're going to get the integral of tangent. What do you think we should do here? What's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. So it might work either way to use sine or cosine as our u. But I did tell you a little bit earlier that it's usually the denominator, didn't I? So I feel like we should probably use the denominator in this case. So let's let our u be cosine of theta, which means du is going to be negative sine of theta d theta. So cosine right here is going to be my u. And I don't have the negative, so I would need to put a negative with my sine, which means I also need to put a negative on the outside. And that sine in the numerator can kind of be grouped over there with the d theta. Or, just to be really clear, let me write what we're doing there. It's like this. We got 1 over cosine of theta times sine of theta d theta. Because I could not do that with the bottom. I can't, the bottom, it'd have to be 1 over cosine times d theta. And that's why we don't want to do that, because we can't deal with that. So this is my u. Put my negative out here, put my negative right here. This is my du. And so I would get negative integral of 1 over u du. Oh, I've got 2 negatives right there. What is our integral of 1 over u? Natural log. So negative natural log of the absolute value of u plus c. And so if we plug this back in, we got negative natural log of the absolute value of cosine of theta plus c. E's and natural logs are so weird because we took the integral of tangent, which seems like it has nothing to do with a natural log, and now natural log is shown up in our integral. Okay, you cannot let sine be the u in this case. Like you could try, but you're going to hit a roadblock because the derivative of sine is cosine, but that cosine's in the bottom. So if you try to pull it over to the side, you'll have 1 over cosine, which is not going to be the du that you're looking for. So, like on one of those first ones, we could have used sine or cosine, and it would have worked. It's only cosine is the only one we can use here. Okay, questions? All right, we got a couple more to do. E's are very easy. E's are so easy that sometimes they're difficult. Sometimes they look like they don't even need a u to u because they're so tiny. And of course, what makes E's the easiest to deal with is that the derivative of e to the x is e to the x, and the integral of e to the x is also e to the x. It is its own derivative. But in this case, we've got an exponent that is more than just an x. So we want to let this be our u. So u would equal 3x, du would equal 3 dx. And so we almost have our du. We just need a 3 over here with the dx, which means the 1/3 has to go on the outside. And if we replace our 3 dx with our du and our 3x with our u, we will get 1/3 integral of e to the u du. What is the integral of e to the u? E to the u. It stays the same. 1/3 e to the u plus c. You're going to plug 3x back in for your u. So 1/3 e to the 3x plus c would be your answer. The exponent is almost always your u in these cases. Okay, here's a slightly more difficult one that we're going to look at. Okay, what do you guys think we should use for the u here? Okay, x squared, that exponent is going to be our u. The derivative of x squared is 2x. We'll put the dx there with it. This is a little like the one that we did for when we were going over the homework. I've got the x that I need, but I also have the 5, and the 5 is a problem, right? So I like to just take that 5 and put it over here on the outside so that I don't have to worry about it. So then if I rewrite this, I've got 5 integral of, I'm going to do e to the x squared right here, and then I'm going to multiply that by x dx. So I'm moving that x over there with my dx in this case. And I'm missing the 2, so I can put the 2 right here, as long as I also multiply by 1/2 out here on the front. Another option would have been to multiply by 2 on the inside and put a 5/2 on the out, or I guess multiply by 2/5 on the inside and a 5/2 on the outside. I think it's easier just pull that coefficient that you don't need out and pretend like it's not there. So whenever we do this, our x squared is our u, and then all of this stuff right here is our du. So we have 5/2 integral e to the u du. Almost left off that integral there because when we integrate, what do we get? E to the u. So if I had have forgotten to write that step, graders probably would have assumed I knew what I was doing and just skipped writing that step, right? So I get 5/2 e to the x squared plus c would be my answer. Okay, questions there? All right, we got one more that we're going to do. And we got the integral of e to the 3x over 1 plus e to the 3x. What do you guys think we should use as the u denominator? Very good. So u is going to be 1 plus e to the 3x. The derivative of that, derivative of 1 is just 0. It goes away. Derivative of e to the 3x is e to the 3x, except for you've got to use a little chain rule here and multiply by 3. And then you have the dx with that. So while you don't really have the e to the 3x with your dx, it is over here in the numerator, and you can kind of pull it over to the side. It will look like this: 1 over 1 plus e to the 3x times e to the 3x dx. And you're missing the 3, so you can multiply by 3 here. 1/3 out front. This part right here is u. This part right here is du. So you've got 1/3 the integral of 1 over u du. What do we get when we integrate 1 over u? Natural log, absolute value of u plus c. So I have 1/3, watch, natural log, absolute value of 1 plus e to the 3x plus c. Do you need absolute value bars there? For this one, you don't have to have absolute value bars because e to any power is always positive and 1 is positive. So it could be written like this, but it also could be written like this. So either one of those would be. All right. The assignment for this one is not going to be all that. Let me go look at it. That was excessive, wasn't it? This is like whenever Belk has something that's like $250 and it's been marked down 17 times and it's only in fact, those might actually be the book numbers from the old textbook. Why have I not fixed this? I've had these new textbooks for like 5 years now. Because that's not even the right page numbers, I don't think. Let's see. Let me go to Canvas. Let me see. I probably just changed it on Canvas and didn't change it there. Let's see. I think you got to click on it over here. Okay, let's see if that's what I'm looking for. So 33 to 43 odd. Okay. And 351. We got I think that will be okay for that. You should see on 341 is going to be your, it is going to be like your problems where you've got some trig and ease, and then your 351 is going to be natural laws. So I guess we also need to go over a free response question. Pull that up. You guys got that? Oh, you want me? I probably need to. It is. Are you?
Yes.
Okay. 341, 33 through 43 odd. 351, 3 through 11 odd. Freeze that there for you while I pull up the free response stuff. It's not going to hurt if you use it though. It'll be, in the end, you'll be fine. Oh, let's see. Well, where do I have this saved at? Because this one is the progress check. And I don't have it saved in the same spot. Maybe it's over here. It will not hurt to use it. You'll be fine. The likelihood that it comes down to that one little thing is very small. Okay, let's see. Also, I maybe should or should not tell you this. Your grades second semester don't matter much. They do class rank off of first semester. That it doesn't count for class rank. You do not want. I mean, you absolutely do not want to like fail classes because your colleges can rescind your you have to send in your grades and they can take it back. I've never known them to take it back off of C in calculus. Like for failing classes or something, just like clearly this kid's going off the deep end, maybe, but not making an A in calculus, never heard of it. So like, it's what really matters this semester. What really matters is that AP exam score, which means you want to do everything you can to make sure that's good, which means that should also impact your grade. But the AP exam score makes sure that you didn't waste all year learning this hard stuff and doing all this work for to still have to take it up. Although it's not a total waste if you don't pass it, because if you do have to take it again, it will be much easier than if you had never seen it. But AP exam is like our main focus. Yeah.
Like, especially if you know, like, the gist of it.
Yeah.
It's like, just make it easier. I would be like, we're like notes and stuff. I would be so
time, but
irritated.
basically a
It's in college. You can just play on your computer. Nobody's going to think, and then I'm not failing again.
Yeah. If you don't get a 3 or better, then you probably need to pay attention when you have to retake it, because you were missing quite a few things. But it should still be easier than if you had never seen it before. I had 18 last year and 14 of them passed. So I had 4 that didn't make it. Pass with 3 or better. Yeah. I didn't have but 1 5 last year. Owen. I'm not really probably supposed to say that name out there, but that I will definitely not say. The year before, I had 12 kids. Everybody passed, and I had 9 5s. No, we'll definitely have 5s this year. I'm expecting a few 5s at least. You guys are a pretty strong class. Huh? Yeah.
I want anybody to think that I'm good at math.
That's silly, Isabella. All right. Isabella, you got to change that attitude a little bit.
Not math. Trust me.
You're good.
All right.
You make it 3, they might be like,
Yeah, they can't force you into anything. So, they can be like... I had a teacher that tried to talk me into majoring in English while I was in college. She was like, oh, you're doing so well, you should major in English. I was like, no. No, thank you. I shall not. Yeah. So, yeah. All right. D's going to have... Part D right here is a little... I might would pick that last one. This other one kind of looks scary because of that part D, but honestly, you can just memorize that. The other parts of it are not nearly as difficult. Oh, let's see. Yeah, that's why I would just memorize the answer and not worry about it all that much if I were you. You're unlikely to see sigma notation on the second question. Honestly, that's like a part I usually mostly take a L on. We can do whichever one you guys want. But the others are pretty straightforward except for the part D and the part D on each one, which is honestly not going to be even that much easier if we go over it because sigma notation is confusing.
Let's just go over the whole thing. Yeah, let's do that.
if I leave my stuff in here in P after 305, like 307, do I still have to pass? If I leave my stuff in here, I'm going to
Yeah. Just go ahead and use it. Okay, let's keep going. All right. Which one do you guys want?
I'm thinking number 1.
I think
I have no idea.
That's the last one is hard. 3.
Wait, which one do you think is hard?
I do not think the third one is necessarily that difficult. It's just we haven't done a ton. Like we haven't done it as much.
Is
But
that it?
yeah, this is 3. I think Part D is difficult on 1 and on 2, but I also don't know that it's going to be that much more clear whenever we go over it. Still one? All right, let's vote. How many of you want one?
I don't know.
I don't know.
I'm with Calc.
Don't
All right.
think about it.
Okay, that's 7 of you. How many are? All right, how many of you want 2? 3. All right, let's do number 1.
What?
All right.
I don't know what to do.
Okay. All right. So, this one is calculator active. So let's pull up Desmos to look at here. Am I still recording? I haven't printed them yet, and the spinner will decide.